All right, welcome to section 8.6, the binomial distribution, Bernoulli experiments. Basically, all of this says that we're going to do something over and over again, and there's there's two results. It happens or it doesn't happen. All right, it's a yes or no situation. There's a probability of yes, there's a probability of no. But the thing that we're doing happens over and over and over and over again. Okay? The best example, practical example of this is example 1, baseball, softball, doesn't matter. So let's say the person has a 30% chance, like they're a proven baseball or softball player, and their batting average is 30%. There's a 30% chance that they're going to get a hit, which means there's a 70% chance that they're not going to get a hit. And baseball plate appearances happen over and over and over again. Okay, so this is a perfect example for this. Okay, so we're going to have a game, and we're going to have 4 at-bats, and there's a 30% chance of hitting the ball. So P is the probability of doing something, which is 30% hitting the ball, and Q is the opposite of that. It's not hitting the ball, and that's a 70% chance. So we're going to find the probability distribution, the frequency distribution for this situation. So what can happen in a game of baseball with 4 at-bats? Okay, and we're going to say we're not going to count walks, right? We're going to, because a walk doesn't go towards your average. So what happens is, if they hit the ball every time, it would be hit, 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 hit. Okay, if they hit the ball 3 times out of 4, it would be hit, 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 no hit, 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 no hit, 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 nope, no hit, 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 or no hit, 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 hit. That's it. So they can hit the ball 3 times in a row and then no hit, or they could hit it on the 3rd, the 2nd, or the 1st time. So like the first time up, they don't hit it, but then they hit it the next 3 times. H is 2 hits. 2 hits would be more of them, right? Because there's more possibilities of this. So then this would be hit, hit, no hit, no hit, and then we get hit, no hit, hit, no hit, and then hit, no hit, no hit, hit, and then the next one could be no hit, hit, no hit, hit. And the next one could be no hit, no hit, 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 and then finally the beginning and the end. No hit, 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 no hit. Hopefully, off to the side here, I made a cheat sheet. So let me double check my cheat sheet here. Dooby-dooby-doo, boom. Yes, yes, yes. So there's 6 of these. Okay, then what else could happen? The hits, you could just have 1 hit in the game. So if there's 1 hit in the game, it would be hit, no hit, no hit, no hit. Or it could be no hit, hit, no hit, no hit. And then the next one would be no hit, no hit, hit, and no hit. And the last one would be no hit, no hit, no hit, and hit. Okay? And then the last thing that could happen is you could have H equals 0. You could go 0 for 4. So that would be no hit, no hit, no hit, no hit. So there's only one way to do that. So if you remember, 1, 4, 6, 4, 1 is one of the lines of Pascal's triangle. So we go 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So those numbers are coming from this, and those are all the combination things. So 4C2 is 4 times 3 divided by 2 times 1, which is 12 divided by 2, which is 6. So 4C2 is 6, because that's all the ways that you can have the placement of 2 hits and 2 no hits. There's 6 different ways, so it's 4C2, and it's 6. And if you do the other ones, like 4C1, that's just 4, right? So that would be 1 hit. 4C3 would be 3 hits, that's also 4. and then 4C0 is just 1 because there's one way to have no hits, and then 4C4 would be all the hits, and there's one way to do that. So the combination is the first part of this. All right, so here's the probability distribution for this. And that's where this formula comes on. So let's go back to the formula page here. So it's CNX P to the X Q to the N minus X. So N is the number of trials. And our trials would be our plate appearances. X is the number of successes. Number of successes. Okay, P is the probability for, right? And Q is the probability against. And that's the formula for this. So we're going to do the probability distribution for this situation. So I've kind of like written, I've written all over this, so you can't really see what I'm doing here. So I'm going to go to another piece of paper like this. Okay, so the first situation would be 4C4. Probability for is 30%, and that'd be to the 4th power, and then 70% against, and that would be to the 0 power. So this and this match. Okay, so 4C4, and then we got 30%, and this matches this, 70%, 0, because this plus this has to be equal to this number here, the total number of trials. So if you think about it, if we do this plus this, the negative x and the positive x cancel out, and that would just be in the number of trials. All right, so then that would be the first situation where we have 4 hits. That's the probability of this. So then we do 4C3 would be 0.3 to the 3rd power, and then 0.7 to the 1st power. So this would be 3 hits and 1 no hit, probability against. So this matches this plus this equals that. Okay, then we got 4C2, 0.3 to the 2nd power, and 0.7 to the 2nd power. So this is a probability of 2 hits, 2 no hits, and then these are all the arrangements of 2 hits, no hits. And that's 6. Bless me. 4C1 would be 0.3. This would just be 1 hit, and then 3 hits and 3 no hits. See how it's shifting? So it's 4, 3, 2, 1, 0, 1, 2, 3, 4, and then the last one would be 4C1, and then 0.3 to the 0 power, and then 0.7 to the 4th power. So this is all the things that can happen. Oops, I need a 0 there. So we can have, this means no hits, because a hit is 30% chance. 1 hit, 2 hits, 3 hits, 4 hits, and then 0 through 4 of the no hits. So we just got to type this into the calculator, and we get all of our answers. All right, so once I get this programmed in, I can do it pretty fast. So I do math menu, go over to probability, and NCR, and it's 4, push myself forward, 4, and then we got parentheses, 0.3, parentheses to the power of 4, push myself forward, parentheses, had to have a drink of water, 0.7 to the power of 0. Now I'm taking the time to type this in because I'm just going to like swap these numbers out. Enter. So there's a very small chance of that happening. 0.0081. So if you hit the ball 30% of the time, going 4 for 4 is less than a 1% chance of doing that. All right. And these are how the probabilities are distributed. So now I'm going to go up and up. So it's a probability distribution. Okay, I'm going to change this to a 3. I'm going to change this to a 3, and change this to a 1, And so here's the next one. So 7.5%. So 0.0756. So there's a 7.5% chance that you're going to go 3 for 4 if your batting average is 300. Then we go up and up. We hit enter. We go over here, and we do 2. We change this to a 2 here, and then we change this to a 2 here. Enter. So there's much better chance that you're going to go 2 for 4 if you have a batting average of 300. So this would be 0.2646. Okay, then the next one, up arrow, enter. Change this in the front here to a 1, and then change this to a 1, change this to a 3, enter. That's the highest probability. So it'd be 0.4116. That makes sense because 1 out of 4 is 25%, and that's close to your actual batting average of 30%. So more likely you're going to go 1 for 4 versus 2 for 4. And then OFER, doing an OFER. Coaches love the OFERs. I had a bad game. I couldn't hit the ball. And a 4 here, and enter. 24% chance of the OFER. So you could be like, Coach, there's a 24% chance of me going OFER. Right? So there it is. Now, since this is a probability distribution, which is the name of this section, well, it's called the binomial distribution. And pause. All right, I got my fruit delivery from the ag people, so I had to pause my video for a second. So this is this is called the binomial distribution. Bi means 2, right? So something's going to happen or something's not going to happen. So I'm hitting the ball, I'm not hitting the ball, right? The ball goes through the basket, the ball doesn't go through the basket. It's just things that are either yes or no, right? And it's repeated experiments. So this is perfect. So what would happen? These are how the probabilities are distributed. So what would happen if I added all these together? Well, it should make 1, right? Because that's all the things that it can be. So if I do that and that together, that's 50%. And then basically that and that and that would make another 50%. So it totals up 1.0000, right? So that's your whole probability. I'm not going to read through all the verbiage of this, but basically it just says that has to be repeated over and over again, and there's a chance of it happening and not happening. N is the number of trials, number of successes out of the total number of trials, probability for, against, and then we saw how it matches up and stuff like that. Okay, example 2 is really simple. The first thing you do is there's 8 trials. We're trying to find the probability of 4 successes. So we want to figure out 8C4. So we want to have, there's total of N trials, and we want X successes. So that's my formula, NX. And then the probability for is 2/3, which means the probability against is Q. So Q is 1/3. And then this number here matches this number always. So whatever's here is there, right? So the X matches the X. And then this number plus this number has to be the number in front. So 4 plus 4 is 8. So we just type this into the calculator and we get an answer. And you saw how I typed that in. So I'm not going to finish this one out. Okay, example 3. It says in 2009, 46% of the male population had never married, right? 7 males are randomly selected from a group. So this is a situation. You're married. P is equal to 0.463. So you're either married or you're not married. So Q would be equal to 0.537. You can't be half married, right? You're either married or you're not married. There's no in between. So the probability of being married is this. The probability against it is that. So 46.3% of the male population, 25 to 34 group had never married. Oh, so these are the never married people. These are the married people. Okay, 7 males are randomly selected from that age group. Find the probability that at least 2 have never been married. Okay, so here's this thing, right, that we've talked about a bunch, right? 2 sevens, 3 sevens, 4 sevens, 5 sevens, 6 sevens, and 7 sevens. Okay, so at least 2 would be 2 out of 7, 3 out of 7, 4 out of 7, 5 out of 7, 6 out of 7, or all 7 out of 7. So you'd have to figure out all of these probabilities and add them together, right? Kind of like my distribution here. If I said, what's the chances of having at least 1 hit, right? So at least 1 hit would be 1 hit, 2 hits, 3 hits, 4 hits. Or you could just subtract off no hits. Okay, so that's what we're going to do here. So instead of finding at least 2, which means 2 out of 7 all the way up, we are going to do the complement, which would be subtracting off finding no out of 7 and 1 out of 7. So this is going to be the probability, or it's 1 whole, and we're going to subtract off these 2 probabilities. Okay, so the first probability is finding none out of 7. So it'd be 7C0. Probability 4 would be 0.463 to the 0 power. Remember, matchy. And then 0.537 to the 7th power. That plus that has to be beginning. Subtract 7C1. So we're trying to find 1 person out of 7. Because it says at least 2. So at least 2 means 2 out of 7, 3 out of 7, 4, etc. So we want to subtract off these 2 to get this answer from 1, right? Because this part plus that part would be a whole 100%. And then 0.463 to the first power, match, and 0.537 to the 6th power. So we have to do 1 minus these 2 decimals. So I'll go ahead and type that in. So we get 1 minus math probability 7C 7C0, push myself forward, parentheses 0.463 parentheses to the 0 power, push myself forward, parentheses 0.537 to the 7th power, push myself forward, minus, let's see, 7C0 do 0 do 7, okay, minus math probability C 7 C1, push myself forward, parentheses 0.463 to the power of 1, push myself forward, parentheses 0.537 to the 6th power. Enter. So there's a 91% chance that you're going to find at least 2. Okay, because they're doing 2 out of 3, all those. So the answer is 0.909, or basically a 91% chance. And that's the lesson. All right. Here are the problems, and that's all I got.